Hello students. In today's class our first topic that we'll be discussing is going to be chemical properties of bases. The first chemical property of base is a reaction of base with a metal. Bases generally do not react with metals, but there are two metals like zinc and aluminium that do react with base to give you salt and hydrogen gas. Let us look at the reaction of zinc and aluminium with a base like NaOH. So zinc reacts with NaOH and gives you a salt called sodium zincate. To understand how it is formed, zinc and oxygen together form zincate ion, that is ZnO2 minus 2. The zincate ion then reacts with sodium ion, that is Na plus. So the valency of zincate ion is 2 and that of sodium ion is 1. When you cross the valencies, you get the formula of the salt sodium zincate. So the salt that is formed here is sodium zincate, and along with this hydrogen gas is given out. Just as zinc reacts with sodium hydroxide to give sodium zincate, in a similar way aluminium reacts with NaOH to give a salt called sodium aluminate. In this case, aluminium forms one ion called aluminate ion, that is AlO2. How is it different from zincate ion? Zincate ion has a valency minus 2, whereas aluminate ion has a valency minus 1. Again, since sodium ion has valency plus 1, the positive and the negative valencies would get cancelled out and the salt will have formula NaAlO2, that is sodium aluminate. So these are the only two metals that react with bases like NaOH, and in both the cases the end product is salt plus hydrogen gas. Let us go to the next property, that is reaction of base with an acid. It is a simple neutralization reaction wherein we know that acid plus base always gives you salt plus water. So you can see few reactions here. Each of these reactions is a double displacement reaction, and you know in any double displacement reaction you just have to exchange the positions of these ions. So Na plus would now exist with Cl minus, and that gives you a salt NaCl. H plus with OH minus gives you H2O. In a similar way, for reaction of any acid and base, your end product always is going to be salt and water. We go to the third and the most important property, that is reaction of a base with a non-metallic oxide. A non-metallic oxide is an oxide of a non-metal. For example, carbon is a non-metal and its oxide, carbon dioxide, can be called a non-metallic oxide. In a similar way, sulfur is a non-metal and its oxide, sulfur dioxide, can be considered a non-metallic oxide. Now, how do non-metallic oxides react with bases? Let us understand. Non-metallic oxide always reacts with base to give you salt and water. And what you find here is that the reaction is similar to reaction of an acid and a base. Just as acid reacts with base to give salt and water, non-metallic oxides also react with base in a similar way to give salt and water. This is the reason why non-metallic oxides are called acidic oxides. So these are the three chemical properties of bases. Let us go ahead to the next very important topic. What is common to all the acids? To understand what is common to all the acids, let us have a look at the chemical formulas of a few acids. So HCl, that is hydrochloric acid, H2SO4, sulfuric acid, CH3, COOH, acetic acid are examples of few acids. Now what do you find common in all of these acids is all of them have hydrogen. So the very first thing that comes to our mind when we think of what is common to all the acids, we think it is hydrogen that is common to all the acids, which is correct. But is this hydrogen responsible for the acidic nature of acids? Because there are also many other compounds which have a lot of hydrogen in them. For example, glucose, the formula is C6H12O6. So glucose also has a lot of hydrogen in it, but is it also acidic? The answer is no. So all compounds that contain hydrogen can't be considered acids. To understand this, let us have a look at one very interesting activity. In this activity, we take a rubber cock and on it we are going to place two iron nails. The two iron nails are in turn connected to a 6-volt battery, a bulb and a switch. When we take solution of acid or base in this beaker, the bulb glows. But when we take solution of substances like glucose, the bulb doesn't glow. This is a clear indication that acidic and basic solutions conduct electricity. But do you know an interesting thing? That what conducts electricity in a solution? The electricity in any solution is conducted by ions. As you can see here in this solution, we have sodium and chloride ions, and the ions move to opposite electrodes. The sodium ion, that is Na plus ion, moves towards cathode, and Cl minus ion moves towards the anode. It is the movement of these ions that conduct electricity in any solution. So if acids and bases also conduct electricity, they also must have some ion present in them. So what is that common ion that is present in all the acids? I think you've guessed it right. All acids have a common cation. Which one is that? So we all know that all acids have got H plus ion in them. Just as all acids have got H plus ion, what about all the bases? Bases, in similar way to acids, conduct electricity because of the presence of hydroxide ion in them. So we can thus conclude that all acids have H plus ion and all bases have OH minus ion in them. So the next question is that is this hydrogen ion responsible for the acidic nature? Again, to get the answer, we'll look at one very interesting activity. In this activity, we'll first look at picture number A. In the first picture, what you can see is the preparation of HCl gas. For preparing HCl gas, we take a dry test tube and in it we put some sodium chloride NaCl. To this sodium chloride, we are going to add a few drops of concentrated H2SO4. A reaction takes place between these two, and let us look what is that particular reaction. So in this reaction, NaCl reacts with H2SO4 concentrated. This gives me a salt that is NaHSO4. The name of this salt is sodium bisulfate. And along with this, what is given out is HCl gas. So this is the reaction that takes place in the test tube number A, and this is the method for the preparation of HCl gas. Now concentrate on figure number B. The same reaction wherein we are preparing HCl gas, and as the HCl gas is given out, we check it with dry blue litmus. We all know that acids have the property that they change the color of blue litmus to red. But when I check with dry blue litmus, there is no change in the color of litmus. No change in the color of litmus is an indication that dry HCl gas has got no acidic nature. Now concentrate on picture number C. Again the same reaction wherein we are preparing HCl gas, but in this case we check it with a moist blue litmus. And what do we observe? The color of litmus changes to red. This is a clear indication that it is the wet HCl gas that has acidic nature. So what do you conclude about the acidic nature of dry HCl? It is not acidic. And what do you conclude about the nature of HCl gas in presence of water? It is acidic. What does this mean? Does this mean that acidic nature is shown only in the presence of water? Yes. Why? What is so unique about it? Why do acids and bases show their acidic or basic nature only in the presence of water? Let us try to get the answer to it. The answer is that the separation of hydrogen ion from an acid or hydroxide ion from a base cannot occur in absence of water. So what is so unique about water? To understand this, let us look at the molecule of water. The water molecule is a bent molecule of this kind. Now in case of water molecule, oxygen atom is a more electronegative. You will understand the meaning of electronegative atoms or electronegative elements in your next standard, that is 11th class. But to just give you a brief idea, an electronegative element is that element or an atom that has got a tendency to attract the electron pairs towards it. So if I say oxygen is more electronegative, it will mean that the electrons that are present in this bond would be strongly attracted towards oxygen atom. As these electrons are attracted towards oxygen atom, the oxygen atom, due to electrons shifting over it, develop a partial negative charge, which is represented by writing delta negative. And since the electrons have moved away from hydrogen atoms, the hydrogen atom develops over it a partial positive charge, and I will write it as delta positive. Molecules of these kind, where they have got two ends of opposing charge, such molecules are called polar molecules. So water is an example of a polar molecule. Just as water is polar, in a similar way, the acids are also polar, because here also the two ends have opposite charges on them. In this case, chlorine is more electronegative, so it will attract the shared pair of electrons towards it. Therefore, chlorine atom will develop a partial negative and hydrogen will develop a partial positive. Whenever we dissolve any acid in water, the negative end of water attracts the positive end of the acid, and therefore the acid dissociates, or we can say splits, into its respective ions. Thus, the separation of H plus ion from an acid will be possible only in presence of water, when the negative end, that is the oxygen end of water, will attract the positive end, that is H plus end of the acid. This H plus of the acid will now separate from the acid and will get attracted towards the water molecule and will now exist along with the water molecule. When this H plus exists along with the water molecule, you are supposed to write it as H plus plus H2O. It is because H2O has attracted H plus towards it. Together, you call it as H3O plus, and this H3O plus ion is what is called as hydronium ion. Now it is actually this hydronium ion, or sometimes we simply write it as H plus aqueous ion. When you are writing hydronium H3O plus, you don't have to put aqueous, because in this particular case you have already shown it along with the water molecule. But if you are writing simply H plus, you will have to put a sign of aqueous along with it. So either you write it as H plus aqueous or you write it as H3O plus hydronium ion. And this is what is responsible for acidic nature. But remember, the separation of H plus from acid has to take place for the acid to show its acidic nature. And the separation of H plus from an acid cannot take place in absence of water. It is because of this reason that acids will show their acidic nature only in the presence of water. In a similar way, what about a base? So let us talk about NaOH. In NaOH, once again, this is the negative end, OH minus, and OH minus has to separate out from NaOH for a base to show its basic nature. This will again be done by water. This time, the OH minus end will be surrounded by the H plus end of your water molecule. And this is what is going to split or ionize the ion, and OH minus is going to separate out from NaOH. Again, after separating out, OH minus is not existing on its own. because it is attracted by water molecule, so it will exist along with the water molecule. And if it is existing along with the water molecule, you are therefore supposed to write it as OH minus aqueous, that is along with the water molecule. I will thus conclude that the acidic nature is due to hydronium ion or H plus aqueous ion, and the basic nature is because of OH minus aqueous ion. Okay, so here I've got a visual for you which can make things a little clear. So you can see H plus getting attracted by the water molecule, and now H plus getting separated from HCl and existing along with the water molecule. This is what is H3O plus, and we call it as hydronium ion. I'll thus conclude that hydrogen ion, after separating from acid, will always exist along with water molecule, is called hydronium ion, and is responsible for acidic nature of any solution. With this, we'll end our today's discussion, and we'll very soon meet with another lecture on the same topic. Thank you so much.